Hello, I'm Charlie Kesker, and this is using dbScan to analyze weekdays and weekends. So for the problem statement of this project, we don't know how many different places a typical IME student travels on a weekday versus on a weekend. Now, IME students are typically known to be the more social class of engineers, and what we want to know is, do they spend their time socializing on weekdays versus on weekends? Do they travel more on weekdays or weekends? So to figure this out, the project plan was to take 5 to 10 data sets from random students that had both weekdays and weekends in their data, manually turn those into CSV files with proper timestamps, so from Greenwich Mean Time to Pacific Standard Time, then use a Jupyter Notebook to import the CSV files into a data frame, separate the data into 2 other data frames, weekdays and weekends, use dbScan to determine the stationary points for each of those data frames, and then export that data into CSV files. And then from there we could perform an analysis on the visualized results and make some inferences. So right off the bat, there were some data collection issues. It turns out there were not a whole lot of good data sets that had both weekdays and weekends in their data sets. Most of them were just on weekdays. So I had to semi-randomly choose 3 good data sets instead of just doing a straight up random number generator. Those were successfully converted into .csv files with the proper PST timestamps though, so that was good. Next, dbScan or dbScant is kind of a play on words here, because dbScan actually ended up not working quite a bit because the data sets were 250,000 to 500,000 rows long. And oftentimes it put too much stress on the processing power of my computer, which is a really powerful computer. As you can see here, this little star would last forever. It sometimes would take an hour. And as you can see here in the task manager, it would take up almost 100% of my memory and over 12 gigabytes of working memory to boot. And it would end up crashing my computer most of the time. So I had to figure out a way to water down the data and make it easier. So the new plan was to simply manually take 2 weekdays and 2 weekends, in other words, separate them with an Excel filter from the 3 good data sets that I could find. Then I would use Jupyter to do all the other stuff that we talked about in the original plan, find stationary points and output them into a CSV file, then run an analysis on the watered down data. So the results and inferences, it turns out that according to the data I used for the project, there were 12 stationary points total for weekdays, which means 12 divided by 6 was 2 stationary points per day. So the average student would travel to 2 stationary points per day, at least during the time they were recording their data. And then on weekends, there were 10 stationary points total. Divided by 6 is 1.67 stationary points per day. So it turns out that weekdays were typically more traveled on than weekends. And from there we can infer that IME students typically are out and about more on weekdays than they relax and travel less on weekends. Now this data is not nearly statistically significant, so as we move on into if I could do it again, I would definitely implement more data sets for validity, and then I would run dbScan on multiple computers so that time is saved and I'm not waiting for half an hour on one data set to run through. And then I would make use of travel points to have a more comprehensive analysis on what students do during each day. So not just looking at the stationary points, but the travel points as well. All right, and that was it for this project. Thank you very much.